Welcome, everyone. Good morning, good evening, wherever you are in the world. Today, we're going to talk about the four-layer production stack that every AI agent needs. And we have two presenters from our side. We have Dipti Reddy, who leads product at Orcus. And then we have Adrian Warman, who leads the solutions architectural team. Uh, yeah, today we'll kick it off with Dipti leading with the presentation, and then Adrian will step in and do the demo on Agentspan. If you have any questions along the way, feel free to drop them in the Q&A, and we'll respond to them in the end, especially in the demo section. And with that, I will hand this over to Dipti. Dipti, over to you.
Yeah. Hi, everyone. Thanks for joining. So I'll keep my part tight, and then Adrian here, he will walk you through a live demo so you can see everything in action. So at Orcus, we open sourced Agentspan a couple of weeks ago. Developer response has been strong and steady, and so we wanted to do a proper walkthrough of what it actually does and why Agentspan exists. Here is the short version. Every team today, as we know, is building AI agents right now, and most of them are about to hit the same wall in production. So this session is about what that wall looks like and how we solve it using Agentspan. So let's get right into it. So every team I talk to today is building agents right now. They're not planning to, but they're building them today. Whether it's engineering, finance, support, operations, everyone is automating with LLMs. And clearly, the experimentation phase is over. Teams have prototypes and they're trying to ship them to real users. That's where the wall is. The question has shifted from should we build an agent to how do we run this reliably in production? And most teams don't have a good answer. The frameworks they used to build were never designed for production durability. Agents crash mid-task with no recovery. Human approvals vanish on server restart. And when something breaks, there's no trace. There's literally no idea what the LLM decided or which step failed. We at Orcus, we've been solving this for years through our durable workflow orchestration platform. And today it's used by Netflix, LinkedIn, Tesla, and hundreds of other customers. It runs billions of executions daily. Agentspan is powered by Conductor. And through Agentspan, we are opening that infrastructure to every developer to build durable agents. I want to be concrete about what breaks in production, but because this isn't an abstract concept. We consistently see three failure modes, and every framework out there hits all three. First, agents run in your process. The moment your server restarts, a routine deploy, and out of memory kill, the agent is dead. There is no state, no recovery. It was on step 7 of 10. You start from scratch. So let's think of a quick example, such as a travel booking agent. Let's say that the agent completed step 1 where it found flights and step 2 where it found hotels. And at that point in time, the process dies. Today, with most frameworks out there, when the process is back up, the agent picks up from step 1, which is finding flights and hotels all over again. However, when you use Agentspan, the agent picks up from step 3, where it books the flight and continues on to step 4, booking the hotels and so on. This is because the agent remembers the state the execution was left off at. Second area that we see constantly break is human approvals. When an agent needs a human to sign off on something, a refund, a trade, a deployment, every framework today handles this by blocking a thread. The agent sits there waiting. The server restarts 2 hours later. That approval, that agent, that job is all gone, and nobody knows why it never finished. Third is when you have a failure at 2 a.m. And trust me, you will have those failures at odd hours. When it does, you have nothing. There's no trace of what ran, what the LLM decided, which step it was on. You'll be grepping through logs, hoping that you thought you logged something useful, and which usually you probably didn't. Today, whether it's LangGraph, Crew AI, AutoGen, OpenAI SDK, none of them offer built-in durability. They're built to run in your process. So when your process dies, they die. And that's the gap that we, with Agentspan, are filling. So what does fixing this look like? It's literally just one line of code. So you wrap your existing agent in agent runtime and everything changes under the hood. Your agent definition doesn't change. Your tools don't change and your prompts don't change. So if you look at my screen here, you'll see that we have the your agent along with the tools. The only thing you have to do is using Agentspan to import the runtime and then do runtime.run on your agent. And that is what makes it durable. So what changes when you add that one line is where the execution lives. It moves off your process and onto the Agentspan server backed by a database. So essentially, you can think of it that your code compiles to a durable workflow on Agentspan. Your process becomes a stateless worker, you can kill it, and the agent keeps running. You can reconnect from any machine and it will still resume from the exact same step it was on. The good thing is if you're already using LandGraph, OpenAI Agents SDK, or Google SDK, or for matter, any of your favorite agentic frameworks, do not change your agents. Just simply bring them in and replace one line. It's not one line per agent, not one line total. It's literally one line. Your graph, your nodes, your handoffs all remain unchanged. So when we were building Agentspan, we thought through what does it really take and what sits between your agent code and a deployment that makes your agent actually work in production. And we came up with the mental model of 4 different areas. The 4 things that have to work for agents to run reliably in production. Now, I will say that these aren't optional extras, they're requirements. If you miss any of them, you're going to have a bad time. So the first one is durability. Agents will survive crashes, restarts, and deploys. This is the foundation everything else is built on. Next, we have coordination, multi-agent pipelines that don't lose state between steps. Safety and control. Out of the box, you get guardrails, human approval, structured output, credential management. The things that make agents safe so you can put them in front of real users. Observability. Here we provide a full audit trail. Every step is queryable and replayable. When something breaks, you can see exactly what happened. So these are the 4 layers, and let me walk you through each one quickly. So the first one, durability, is the foundation and the hardest to truly appreciate until you've been burnt by the lack of it. So the core idea here is that the agent state does not live in your process. It lives on the Agentspan server in a database. Your process is just a stateless worker picking up tasks, can die at any point, and execution continues the moment any worker reconnects. That worker can also be on a completely different machine. What this means practically: if your agent is on step 7 of a 10-step pipeline and your server goes down or your process goes down, once it's back up, it picks up at step 7 when it comes back, not step 1, but step 7. As I said, this is powered by Conductor on the hood, the same orchestration engine running in production at Netflix and LinkedIn. We did not reinvent this. We simply made it work natively for agents. So once you have durable execution underneath, multi-agent coordination becomes really elegant. Out of the box, Agentspan gives you 8 coordination strategies: sequential, parallel, handoff, router, swarm, round robin, random, and manual, all through the same agent class. You don't learn a different function for each pattern, you just set a parameter. And that's what you'll see right here, where I set parameters strategies parallel or strategies handoff as examples. Sequential means that one agent feeds the other. The output of a researcher agent becomes the input of a writer agent, for instance. The whole pipeline is one durable execution. If it crashes halfway through, it resumes from the exact step that failed. You're not rerunning expensive work just because of an infrastructure hiccup. Parallel, for example, means all your agents run at the same time and results get aggregated. This can be useful for things like when you're running a market analysis and a risk analysis simultaneously. Handoff means the LLM itself decides which specialist handles a request. You give it a sub-agents, and it routes intelligently. All of these different multi-agent strategies are durable. Every strategy, every pipeline you state is always persistent. So safety and control. This is the layer that makes your agents safe to put in front of real users. We offer 4 tools. Guardrails. Guardrails will validate every agent output before it reaches anyone. So you can use regex patterns to block sensitive data like social security numbers, credit cards. You can use an LLM as a judge for semantic checks, tone, content policy, accuracy. or custom functions with any logic you need. When a guardrail fails, you choose the behavior, such as retry, ask the LLM to fix itself, raise an error, or escalate to a human. Our human in the loop is one decorator. You mark a tool as requiring approval, the agent hits it, pauses, and the state is held on the server with no timeout. We're not talking seconds or minutes, indefinitely. Someone approves it from Slack, from a dashboard, or from code. The agent will resume exactly where it stopped. There are no blocked threads and there's no lost state. Structured output means you define the shape of what you expect back and the agent guarantees it. If the response doesn't match, it retries automatically. Lastly, credential management means your secrets live encrypted on the server. Tools resolve them at runtime. Nothing is hard-coded, nothing is an environment variable, and nothing is in Git. The fourth layer is observability, and this is the one teams only appreciate after they've been burned at 2 a.m. Every execution is automatically logged. Every step, every tool call, every LLM prompt, every token count. There's no instrumentation code. There's no setup. It's simply on by default. You can query executions by agent name or time window. You can also see them at a glance to see which ones completed, which ones failed, and how long they took. And the one that really matters, replay, you get that as well out of the box. You can step through a failed execution and see exactly what happened, what the LLM decided at each step, what the tool's inputs and outputs were, precisely where it went wrong. So now when your agent fails at 2 a.m., you're not guessing, you're watching a recording. Token and cost tracking is built in as well, so you know what your agents actually cost per run. It also plugs into OpenTelemetry and Prometheus if you already have observability infrastructure. So let me make this concrete with a before and after. So without Agentspan, your process dies, agent dies, your progress is lost. There are no retries when tools fail. Human approval is a while loop that times out. When something breaks, you grep through logs. Multi-agent systems are ad hoc glue code, and every agent is a one-off project. Testing literally means you're running it and you're hoping and praying. Now on the right side, here it's with Agentspan. Here your process dies, your agent resumes from the exact step. First step retries with configurable backoff. Human approval is simply one decorator. State waits on the server for as long as you need. You get full execution history, queryable and replayable. You also get 8 multi-agent coordination strategies and over 100 examples to start from. The left column is the honest state of the ecosystem right now. Every team building agents is living there. The right column is what we are offering. So how do you get started? You have 2 ways in. One is build. You can use our native SDK from scratch. It's one class, one decorator, one function. In fact, if you're starting fresh, it's the fastest path to a production grade agent. However, if you've already built something on your favorite platform, such as an Open AI Agents SDK, Google ADK, LangGraph, we offer drop-in compatibility. We have several examples showing the exact migration for each framework. Your definitions stay unchanged. You're simply adding durable execution underneath what you already have. It's your agents, your code, and they simply just stop dying. So how do you get started? We have pip install Agentspan here. I also have a QR code. Agentspan server starts once you do the pip install Agentspan. That spins up the local server at localhost 6767 with a full visual dashboard. You don't need an account. You don't need an API key. You can just point at your LLM and you go. Docs and examples are at our website, agentspan.ai. GitHub is at github.com, agentspan.ai. If you have any questions, please join our Discord channel. It's active and we're there to help you. That's the overview. I'll hand it over now to Adrian for the demo, and we'll do questions after that.
All right. Thanks, Deepti, for that. Okay, so I'm just going to kind of show you a little bit about how Agentspan works in a small little demo. We'll go through a few examples. But pretty much once you get your Agentspan server set up and running, which only takes a couple minutes, this is pretty much what the UI is that becomes available. And if you're already familiar with Conductor a little bit, you'll notice it's pretty similar. That's pretty much just because it's built on top of Conductor, right? So it makes an easy transition. So before we get right into it, I just wanted to show a couple of the parts of the UI that are usable. So first we have our execution history here. So I can view all of my previous agent runs here. I can click into any of them and view, what happened in them, and I can inspect them. We'll get into a little bit more in that later. There's also my list of agent definitions right here. So any of the agents that I've created, when I've defined them, I register them with the server, and then I can see their definition in here. We also have this credential settings right here. So this is where Deepti had mentioned you can add all your credentials. So I'm going to use OpenAI for my examples. I could also use like an Anthropic key here. I could have like a Slack API key here if I wanted to use that. But this is pretty much where all your secrets can be stored so that you're not having to hard code them in your agent definitions or anything. You can just add them here and it becomes available to your agents. So before getting in right in, so I have this quick example of just a really simple agent that's just going to be like a weather agent, right? And using the Python SDK, it's pretty much as simple as, I'm going to create this Python function called getWeather. And really all it's going to do is some geocoding, it takes in a city name and it uses an open source API to essentially just get the coordinates and then find some current weather data on it, right? So pretty simple Python function. And then my actual agent definition is this block right here. And it's pretty much just the name of my agent, the model that I want to use. And then it's also its set of instructions. So for this one, it's pretty simple. And then you'll see right here in the tools section, this is where I'm basically giving it my get weather function as a tool. So it can basically make a call to that tool on its behalf, right? So when I run this, can come in here and we can start with, let's just grab the, the weather for Seattle. So if I run this, even though I started the process here, it basically started the process in the Agentspan server. So if I go to my executions, then I can see this agent running right here. So if I click on here, it already finished because it's a pretty quick one. But this pretty much is where we can see that observability and we can see each step that the agent took. So it just made an LLM call to the model that I told it to. It attached the instructions and the message, the prompt that I provided. And in its output right here, we can see that it made a tool call and it knew basically to just parse the name of the city I passed in and pass it into the get weather tool that I provided it. So then we can see here's that tool call right here. If we click on that, we can see some information about this, being triggered. It has a task reference call, a task execution ID, the scheduled time, so you can keep track of all that stuff and how long it took. If we go to the input, we'll see it grabbed the execution ID or token from my credentials to be able to call the LLM. And then it outputted this nice weather data, which we can see over here in the CLI, it populated over there as well. And then pretty much after this run at the end, it does this a second turn where it essentially goes back into the LLM and it'll sort of do a check on its results. And it does sort of like a verification to make sure that it liked the results it got. It's a little tricky to recreate, but I have seen before where maybe like the get weather tool it doesn't parse the city name correctly and maybe it passes in a null value. So then the get weather tool comes back with a null result and it basically does a recheck and goes, well, we're not satisfied with that result. So it'll actually automatically retry it again and it'll look at its previous results and see what it did wrong and try to correct it and make the call again. So that's pretty much a very simple agent run right there. And let's just quickly look at the actual definition of the agent itself. So if we look at the weather agent right here in agent definition, we can see here's my agent and here's its list of tools. So if I were to provide it a whole set of tools, we would see all of those right here. And really under the hood of all this is conductor workflows, right? But rather than you having to go in and define every step of your workflow, Agentspan creates those workflows for you based on the type of agent that you're creating. So because this agent was just a simple tool call agent, it basically created this workflow right here. We don't really need to get too into every step of this workflow, but it's pretty much just showing like how this is running on top of Conductor really. And so Agentspan takes care of defining all of this and validating all of it and checking it. So this is the full workflow. So if we actually go back into that previous run and we go into this debug view, we can actually see each step from the actual workflow that was running behind the scenes, right? So we can, and we can observe each step. I could look in here and see what the input of this step was and the output. I could come in here and see, what was input and output of this one, see some summaries, how long it took to execute, things like that, which really helps with debugging things, right? Uh, so that's just a simple example of showing of one city, but let's even try another one where we can do like three cities at once. So we'll do Seattle, Toronto, and Berlin. So if we run that and we look at the agent run, we'll see that's pretty similar, except it actually recognized that there were three cities that it needed to do. So it fanned out and did three get weather tool calls. So if you look at the output here from the LLM, it actually did those three tool calls and it parsed one city to each one like that. And again, it basically at the end just creates the output together. So now over in the CLI, now I see my three cities together. So that's how they can be also very dynamic. I only defined my agent one time, but now I can pass, any number of cities in that I want. And just to kind of touch a bit on the durability aspect of it, I actually have this other run that we can do where it's the same agent, but I just hard coded it a little bit. So it's going to do 10 cities and it's going to do a little bit of a pause in between each one or a timer just so it takes a little while. But when we run this one and we go to this agent, we'll see it's doing 10 get weather calls. So there's 10 cities that I'm having it grab. And if I expand on this, we can see the fan out of those 10 get weather tool calls. And over here, you'll start to notice that it's starting to go through those cities. So Tokyo, Sydney, London, New York. But if I were to come in here and kill this process, it didn't quite finish, right? And I only got halfway through my run. But if we actually look at the agent run itself, it's still in a running state. Nothing was really lost. It remembers those previous cities that I already did, and now it's basically able to continue running. Now, it can't do any additional get weather calls only because in this instance, my get weather tool was running in my process. So it no longer has that tool available, but it's still waiting for it to come back online. So pretty much what we can do is now resume this, and I can resume it now, which I'm going to, but I could also resume this a week from now or a month from now, 3 months from now, and it'll still remember where it was in the process. So nothing's going to be lost. And if you're familiar with Conductor, you'll know that Conductor workflows all execute with a unique workflow ID, which we can see at the top right here. And the agent span works pretty similarly. So if I basically just reestablish a connection to this exact instance, then we can resume from where we left off. So if I come in here,
Adrian, we have a question from Mario. He's
yeah.
asking, from what I've seen, all keys, prompts, responses, etc., will flow through the agent span server. Is my understanding correct?
Yes. So pretty much all data associated with the agent is going to go through the execution inside the server.
Perfect. Thank you.
Mhm. Okay, so let's go ahead and just resume this call here. So I basically am just going to reestablish connection to this instance. And when we do that, we can see that, did Tokyo, Sydney, London, New York, and Tomsk. And now it actually remembered where it was. So now it can just continue from where it left off. So it did Paris and then Dubai and Toronto and then Berlin. So nothing was lost, right? It was able to remember exactly where it left off from and continue from there. So, which is great because if you have an instance where, this is a very simple one, but let's say you have an agent that could be running for like a week, right? It could be doing massive amounts of like data manipulation and fetching and all this kind of stuff. And then, halfway through, you've already spent millions of tokens and, a lot of time running this agent. and something were to happen, like the process itself dies, now you're having to not only respend that time again running it again, but also you're going to have to respend all of those tokens all over again. So it can end up being pretty pricey, right? And this also applies to if the agent server itself goes down as well. So if the agent server went down, because we're persisting the state of every step as it goes along. Once the server comes back online, it'll still remember where it was in the process, and we can continue from where it left off. So that's pretty much a good example of a simple agent run and some durability. But we also have a couple other features. So I just wanted to show a quick example of some coordination with a sequential pipeline.
One more question from Mario, Adrian, is
Yeah.
that
Mhm.
is there any support for obfuscating that data on the server? Because he has concerns about proprietary data that is flowing through the Agentspan server.
hmm Yeah, you can actually have you can create guardrails, which basically you can have to prevent any sensitive data from going into the actual workflow execution. Conductor also does support masking parameters, which basically you can uh, hide any sensitive information, which I believe you can also apply to agents. So it's made to be very secure. So it can hide any sensitive data, and also you can put guardrails into your agent definitions to prevent it from trying to throw in anything sensitive in there as well.
One more question is how can this integrate with Conductor? Can an Agentspan agent call be integrated with a workflow?
Mhm. Yeah, so there's one way that it actually works really well to complement each other. So in a standard conductor, we have the MCP gateway, which essentially allows you to predefine your workflows right in Conductor, and then you can expose them as like an API call. And then in your agent definitions and agent span, you essentially add that workflow API call as a tool. So then your agents now have the ability to call your workflows in Conductor. Yeah, so they do kind of complement each other in that way, where because an agent span a lot of these, simple tool processes you're having to define in like a Python function, right? But if it's something a lot more complex than that, and you want to have a lot more, control over it using like conductor workflows, then you basically just expose them as a tool to your agents. Yeah. Okay. So now I'm going to show this one, which is basically a simple example of some coordination with multi-agents. So this one's going to be a sequential pipeline. So the idea of one agent passes off to another and passes off to another, and it pretty much follows that same pipeline every time. So in this example, we're going to have a researcher agent that's going to do some research on a topic. It's going to pass its data onto a fact checker agent that's just going to sort of make sure that it pass any checks. And then also another agent that's going to write it and another one that's going to do a final edit. So this is where we can actually add some guardrails in here. So in this guardrail I created, it's just for no emails. So I'm basically going to be able to tell my agent to remove any email addresses from its output. So we're providing it a little bit of a guardrail there. And then I can also have another guardrail, something like if there are placeholders at the very end in the writer to have it replace those, so those don't show up in the final article. So things like that. So because we have four agents, we're going to define all four of them here. So again, it's pretty much just the name of the agent, the model we're going to use, which I'm just using the same one for each one. And then it's each agent's set of instructions. And then I'm just attaching the guardrails to the ones that need it. So I'm attaching the no emails guardrail to the researcher, and I'm attaching the no placeholders to the editor agent, right? And then right here is where we're defining the actual pipeline. So we're saying the researcher, pass to the fact checker, pass to the writer, pass to the editor, right? So when we actually do this run, we'll clear this. So I can say something like, I want it to do some research on AI agents in production 2026, right? So if I go ahead and run this, we'll see it's going to run this pipeline researcher. So if I go out to here, we'll see that it kind of starts with this top level workflow. And this is basically the actual pipeline workflow. This is where each one it's going to map out the passing from one agent to another. So if we update this, yeah, we'll see. So the researcher one finished, and now it's passing on to the fact checker. But this itself in the researcher one is a separate execution. So we can view this execution, which these ones aren't very complicated. They're not really calling tools. They're just a simple LLM call. But we can actually see what the output is from this agent. And this is what is going to be passed into the next one. So if I come back out here and look at my pipeline again, we can actually see, clicking on here, we can see, this was the output of this specific agent. And then, then we can see what the output of the first writer was. And so we can actually see the separation there and debug each one individually. And then at the very end, it will reach its final editor and give me this nice article output here, right? And then pretty much just for fun, I added some cost breakdown of, the total time it took for this agent pipeline to run, how many prompt tokens, total tokens, and estimated cost. So that's just for the UI purposes or demo purposes to show. But this is pretty much an example of how you can have some handoff between from one agent to another. And some of the other coordinations that you can have is, this one is predefined, right? But you can also have, you expose agents as tools to other agents, and then it allows them to sort of make decisions of what agent to run next, based on results from previous runs, right? Something like that. But sometimes you also want to have some human interaction, right? You want to have human approval, like, have the human decide what next agent to run, or maybe it needs some approval from an end user or, someone else to before continuing on. So one of the tools that you can actually add is a human tool right here. So I have this other example, which is basically just like a fraud review checker, like an agent that might be like monitoring bank transactions and is, is doing like some kind of fraud detection. So in this one, we basically just define our tool, request approval, and we use this human tool right here, which if you're familiar with Conductor at all, it's very similar to human tasks in a Conductor workflow. So pretty much I've just defined all this, what my human tool should do. And then I've defined my agent, and then in its tool set, I basically just gave it the request approval human tool, right? So if we go ahead and run this one, and this one just for demo purposes, I'm just going to have it do based on text. It's not actually looking at any bank transactions. So I could say like a $50,000 wire transfer to an offshore account that is 3 days old, something that would be pretty sketchy. So if we run this, we can look at the agent run right here, and we can see, oh, it actually decided that that wasn't a big deal, which it should have been, but let's try it again. Maybe we need to do more money. Maybe something like that. We'll see if it actually does it this time. Okay, so this one was a little better. So in this one, it basically decided that, so I gave the inputs, a set of instructions, the message that I attached to it, and its output, it did a tool call, and it's going to do the request approval human task. And you can see the type there is human. And right here, we can see in the run, and as we refresh this, it's basically just waiting for someone to interact with this. And in this example, you can see in the CLI, I basically just have, I can approve it right in here, but I wouldn't have to. I could kill this process and start it up again later. It could be, a week from now that I decide to make a decision on it, but basically my agent is now just going to wait until something interacts with it. Now, it doesn't have to be like a CLI interaction, right? You could have a Slack integration and you could have it basically send a Slack message and you do the approval there. It could be, some other notification system or like email, however it is that you design it. But let's just say I came in here and approved it. So then it made its final decision. And so now it updated and completed. So that's pretty much just a quick example of how you can have some human approval. So you don't necessarily always want to give your agents free run to just do whatever they want. So if there's like any critical point where, you have your agent like a travel agent, right? And it might do some actual booking for you, like book flights and hotels, you could have it basically create a full itinerary and create a full, here's what it would pay for. But before it actually charges anything, you could basically have a human task that then waits for human approval and be like, do you actually want to book this? Something like that, right? So you can have a little bit more control over your agent execution and also some back and forth, right? So you could create an agent that talks to an end user through Slack messages or your own custom UI, something like that. Um, yeah, so that's basically just a quick overview of some of the different types of agents you can do and the ways that you can run them. And again, this is fully open source, so we actually do have right here. This is the GitHub right here, which is fully accessible, and it has a bunch of examples in here. If you also go to agentspan.ai, it has the full examples on here, a quick start guide of how you can run this on your local machine. And you could host it in like a Docker container or something, or you could host it somewhere else if you wanted to. But it is fully open source and self-hosted. And then we also do have in this tab up here a bunch of examples that you can run through as well. There is also a Claude skill. So if you want to enable the Claude skill with use Claude code, then you can have sort of a learning experience with it and ask it, what the kind of things it can do, and it can help you build some simple demos and things like that to help you explore it. Yeah. All right. Thank you. Amit.
Thanks, Adrian. Yeah, so folks, if you have any questions, put them into the Q&A tab and we'll start responding. One more question from Mario here. He's asking, does the agent decide whether or not to wait for the human approval, or is it a hard gate? And the reason he's asking is because in the example that you shared, Adrian, it seemed like the agent had some leeway in the money example that you were
Mhm.
talking about recently. Yeah.
Yeah, I mean that's mostly just because for my example, I made it extremely simple, so its set of instructions were very basic.
Mm.
So I mean it's depends on your complexity, right? So the better guardrails you give it and the better instructions you give it, the better it will be able to react. I'm also using GPT 4.0 Mini, which is a pretty lightweight model for simple demos. So those kinds of things can definitely come up in like those kind of quick examples. But yeah, I mean, and I basically gave it the option to decide if it was a red alert and decide whether or not to do a human. But you could also make it have to do a human approval if you really wanted to. Yeah.
Thanks. Can I tell the agent after every change to make a commit and have that carry over in every scope?
Yeah, so pretty much you can update your agent definitions and it will update it as you see fit. Yeah.
Okay. Okay. What happens to a human approval request if the agent span server restarts while
hmm
waiting?
Yeah, so because we're saving this, the state is persisted throughout the whole execution, even if my process had died, if the server had died, it will basically still just be waiting for that approval to come back. So if my server were to have crashed in the middle of that, once I bring it back online, it will just resume in that waiting period for the human task. Yeah.
Perfect. I think we have one more question here. How does agent span handle switching between different LLM providers?
Yeah, so that's pretty much as simple as a one line change. So in your agent definition, you're defining its provider and model. So I believe the syntax is like OpenAI slash GPT-4o Mini, for example. So if you wanted to do a different model, you would just do like Anthropic slash whatever model you'd want to use. And then also there's the way a couple line changes, you can bring in your own providers as well and your own agent definitions as well.
Cool. Cool. All right. Any more questions, folks, from the audience here? Going once, going twice, going thrice. All right, cool. Well, thanks everyone for joining. We're very close to the 11:45 mark here Central Time, but really appreciate all of you hanging out with us for the last 45 minutes. I hope this was interesting. We will definitely follow up with you over email, and if you have further questions, we'll be happy to take them from there. Thanks everyone, and have a great rest of your day. Bye.